This tutorial demonstrates how to train a multilayer perceptron for regression using SciKit-Learn. The data we use in this tutorial is taken from a recent model of small molecule adsorption to transition metal nanoparticles. Specifically, we use density functional theory calculated values for the adsorption energy of methyl, carbon monoxide, and hydroxyl radicals to silver, gold, and copper nanoparticles ranging in size from 55 to 172 atoms. A link to download the data used in this tutorial can be found in the description of this video. In order to upload training data, we first click on the Dropbox link in the left sidebar. This will bring us to the Dropbox page. We can then click the Upload button. Then, when the browser's upload window appears, we navigate to where we downloaded the training data and select it for upload. If the upload was successful, the file will then be visible in the Dropbox. Next, we select the Bank Workflows button in the left sidebar, which brings us to the Bank Workflows page. We then search for the Python ML-Train regression workflow owned by the Curator's account and copy it into our account. Next, we can create a new job by selecting the Create Job button in the left sidebar. This will bring us to a new job on the Job Designer page. First, we will give the job a friendly name, such as Python ML Tutorial. Then we will click the Actions button and choose Select Workflow. This will bring up the Workflow Select dialog. We then search for Python ML-Train regression and select it. The Job Designer changes now that our ML training workflow is selected. The Materials tab has now been replaced with a Dataset tab. Just as the Materials tab shows a preview of the materials the job will use, the Dataset tab shows a preview of the dataset once it is selected. To select a dataset, click the Actions button and choose Select Dataset. This will bring up a Files Explorer containing all files presently on the Dropbox. Choose the training set that we uploaded earlier. A preview of the data then appears on the Dataset tab, indicating that the data has successfully been loaded. We have now chosen our machine learning workflow and training set. Select the Workflows tab, and we can see our training workflow. We can see two sub-workflows available, Setup the Job and Machine Learning. The Setup the Job workflow contains instructions to copy in the training data. Caution: the Setup the Job sub-workflow is automatically configured during the training process. Modifying it can disrupt creation of the predict workflow, leading to inaccurate results or a failure to generate the predict workflow. Select the Machine Learning subworkflow by clicking on it. The following workflow units should now be visible. Setup packages and variables. This configures the job and downloads all required packages with pip. Data input. This reads the training data from the disk. Train test split. This unit handles the splitting of the dataset into the training and testing set. Data standardize. This scales the data such that it has mean 0 and standard deviation of 1. Model train and predict. This unit handles the model's training and prediction. Parity plot. This draws a plot of model predictions versus training data and saves it to the disk. This plot is then shown in the Results tab. We will begin by configuring our machine learning subworkflow. To begin, select the Important Settings portion of the workflow editor. Then set target column name to PBE, BE, EV to define the target column of the training set. Then go back to the Overview portion of the workflow editor. We can now demonstrate how a workflow's unit parameters can be changed. Begin by selecting the Model Train and Predict workflow unit. We can then scroll down and change the hidden layer sizes argument from 100, to 100, 100 to make our model contain two hidden layers of 100 neurons each. We also change max iter to 5,000 to train for up to 5,000 iterations. Then close the dialog. The workflow has now been configured and we are ready to train. Click the check mark in the upper right of the job designer in the header menu to save the job. We now return to the Job Explorer page with the job in a pre-submission status. We can now run the job and wait for it to complete. After a few minutes, the job will complete. We can then visit the Job's Results tab, where we will see that two properties have been calculated. The first, Machine Learning Model Train and Predict, is the predict workflow that was generated by the machine learning job. The predict workflow can be used to leverage the trained model for additional predictions on new data. The second result visible is Machine Learning Parity Plot, which contains the predicted versus actual values for the absorption energies we trained the model on. This concludes this tutorial on training a new machine learning model.